we have limit as x approaches infinity of square root of x plus 9 minus square root of x plus 4. So the first thing to do is always look at what's happening as x approaches infinity. We see that they both go to infinity. So it's infinity minus infinity. A lot of students will say this is just 0. But sometimes it's not true. So you can never conclude that it's going to be 0 immediately. You want to show your work here. So the way you show your work is by multiplying the top and the bottom by the conjugate. So we're going to multiply by square root of x plus 9 plus the square root of x plus 4, top and bottom. At the top, you're in a situation where it's a minus b times a plus b. And this is a difference of two squares. So you'll just have a squared minus b squared. So oftentimes when you're multiplying by the conjugate, that's the situation you're in. So we can simplify this. And now the a is just a square root of x plus 9. The b is a square root of x plus 4. So we're going to square each one of those. And then we're going to subtract them. So that's what the difference of two squares is. And we're going to have the denominator as square root of x plus 9 plus the square root of x plus 4. At the top, the x's are going to cancel. So I have limit as x approaches infinity. And then 9 minus 4 will just be 5. So it'll be 5 over the square root of x plus 9 plus the square root of x plus 4. Okay. We know that the bottom is going to go to infinity. So you can really think of it as this being 5 over infinity, which will be 0. But to show your work, you need to divide by the highest degree term in the denominator. So we see that x on the bottom here is the greatest term. So you want to, because it's in the square root, it's really the square root of x is the greatest term. So I'm going to divide everything by square root of x, or in other words, multiply by 1 over square root of x. So top and bottom. So then at the top it's just 5 over the square root of x. And we want to bring the square root of x inside the square root. So really that turns into just square root of x plus 9 over x. Right? So the square root of x goes inside the square root as just x. Okay, because this you could just break it up as square root of x plus 9 divided by square root of x. Okay, so the x's will cancel, and so you'll have square root of 1 plus 9 over x and square root of 1 plus 4 over x. Now as x approaches infinity, 5 over square root of x will go to 0, 9 over x will also go to 0, and 4 over x will go to 0. So you're really left with 0 over the square root of 1 plus the square root of 1, and that's just 0. Okay, let's try another one. Let's say we have limit as x approaches infinity of square root of x squared plus 25 minus the square root of x squared minus 1. We know that each one of those square roots will go to infinity, so we'll have infinity minus infinity. So now we're going to multiply top and bottom by the conjugate. So it'll be square root of x squared plus 25 plus the square root of x squared minus 1. Okay, at the top we have a situation of a minus b times a plus b. So that will just be a squared minus b squared, where square root of x squared plus 25 is a, and square root of x squared minus 1 is b. And then we'll have square root of x squared plus 25 plus square root of x squared minus 1. Next, we see we have x squared minus x squared, and those are going to cancel. So we have limit as x approaches infinity, and then 25 minus negative 1 will just be 26. It'll be 26 over x squared plus 25 plus the square root of x squared minus 1. Here it's really 26 over infinity, which is just 0. But the way to show your work is to find the highest degree term in the denominator. That's a x squared. And here the x squared is inside the square root, so it's really the square root of x squared as the greatest term. Okay, now the square root of x squared normally is equal to the absolute value of x. But here, because we're looking at x going to positive infinity, in other words, we're looking at a really big positive number, we can drop the absolute value of x and we can just say x. Because the absolute value of a positive number is just that positive number. Okay, so going back, we could just multiply the top and the bottom by 1 over x. Okay, so I have limit as x approaches infinity, 26 over x. And now the 1 over x can go inside the square root as 1 over square root of x squared. Okay. So, because to show our work, over here, we said that square root of x squared equals x. So 1 over square root of x, square root of x squared is equal to 1 over x. Okay, so this will go inside as 1 over square root of x. And really, you're just dividing the insides by x squared. So you'll have 1 plus 25 over x squared plus 1 minus 1 over x squared. Okay, so just to show some extra work, what we're really doing is the 1 over x comes inside as 1 over square root of, as 1 over x squared, and you're multiplying the x squared and then 25. And that's just 1 plus 25 over x squared and then the square root once you distribute it out. Okay, now we need to recognize that 26 over x will go to 0, 25 over x squared also goes to 0, and 1 over x squared goes to 0. So currently what we have is 0 over the square root of 1 plus the square root of 1, and my limit is just 0. Okay, now let's look at x approaching negative infinity. So what happens there? The limit as x approaches negative infinity, I have the square root of x squared plus 3x plus x. Here, the square root of x squared plus 3x goes to positive infinity, and so does x. So this is a situation where you have infinity plus infinity. We shouldn't dismiss this. We shouldn't say this goes to infinity. We should make sure that this doesn't go to a different limit. So let's multiply the top and the bottom by the conjugate. So that will just be the square root of x squared plus 3x minus x. So we do that to the top and the bottom. At the top, we're going to distribute. Well, sorry, this is a difference of two squares. So really, this is the a and this is the b. So we can just say its limit as x approaches negative infinity. It's a squared minus b squared, which is x squared plus 3x minus x squared, all over the square root of x squared plus 3x minus x. So we have limit as x approaches negative infinity. Notice we have x squared minus x squared. That goes away. And all you're left with at the top is the 3x. And at the bottom, we have the square root of x squared plus 3x minus x. And if I was to look at the limit, I would basically get infinity over infinity minus infinity. And we don't know what that is. So we need to do more work. So we want to look at what is the highest term on the bottom. That's the x squared. And the x squared is inside the square root. So that's really the same thing as the absolute value of x. And because we're looking at x approaching negative infinity, here I'm going to say it's negative x. Okay, and just to recall, we know that the absolute value of x is positive x if x is greater than or equal to 0, and negative x if x is less than 0. And since we're looking where x is approaching negative infinity, we're certainly in the bottom here. So we're going to replace it by negative x. So at the top, we're going to multiply by negative 1 over x, and then same thing with the denominator. So I have limit as x approaches negative infinity. I have negative 3. And the bottom, the negative 1 over x is really 1 over x squared. 1 over square root of x squared, we said. So it could come inside the square root as just 1 over square root of, as 1 over x squared. So what I'm saying is this. So I just want to make sure we're clear on that. So it's 1 over x squared plus, 1 over x squared times x squared plus 3x. Okay, and this we can think of as just negative 1 over x when it comes outside of the square root. So essentially you're just dividing the inside of the square root by x squared, and you just have 1 plus 3 over x in the square root. And now negative x times negative 1 over x would just be positive 1. And let's see, 3 over x will go to 0. So you're left with negative 3 over the square root of 1 plus 1. And it'll just be negative 3 over 2. So your limit is negative 3 halves.